In this video, we'll talk about how do we test other types of hypotheses about beta j. So far what we've done is we have set up our null hypothesis in such a way where we said, let's hypothesize that beta j equals 0, which is to say that the effect of xj on y, holding everything else constant in the population, is 0, right? But what if this was something else other than 0? So what if this was 1? So let's take an example here to see what we could do if we hypothesized a different value in the null hypothesis. So here you see we are trying to estimate income elasticity, where we are saying that the log of consumption depends on the log of income, family size, parental education, etc. So this is our population model, and we are interested in testing the hypothesis for this coefficient here. So this population parameter here. So we can set up our null hypothesis in such a way where we are testing. The null is basically saying we are hypothesizing that this elasticity is unitary. So the elasticity here is unitary, meaning it is 1. And this is what we want to test, right? So we want to figure out how far is our estimate of beta 1. So remember the t-statistic. We want to see how far are we from this hypothesized value beta j, which is 1, relative to the standard error of beta hat j. Okay, so we're gonna, instead of 0, we are just putting 1 here. Okay, so that's the only difference. In general, we can write out the null hypothesis in this way. So no matter what our hypothesis is, 0, 1, 2, or 100, we can write out any type of constant that we want to state in our hypothesis. Okay, and so we can extend the t-statistic to be this value that we are hypothesizing, right? So then we are saying what is the difference between our estimate versus our hypothesized value relative to the standard error. Okay, so this is really how you can interpret that t-statistic. This is really the formula that you should run with when you're thinking about the t-statistic, okay? And, obviously this is the expression, but ultimately we know for hypothesis testing, we will assume either a one-sided or a two-sided alternative, with the two-sided being the most common one, okay? And we're going to choose critical values the same way as before. So nothing really changes other than that t-statistic, okay? Notice that if we wanted to specify our alternative hypothesis for that model that we just specified, we can write our alternative in this way. So we can say that beta j, or beta 1 in our case, is not equal to 1, okay?